Sam Brown is in Game 7 for the Boston Celtics. She's a true baller. She wants to find out the characteristics of the ball's flight as it goes off her hands and into the hoop.
I hypothesize that a position versus time graph of the flight of the basketball will be a quadratic equation, while the velocity versus time will be constantly negative but a linear equation, and the acceleration versus time will be a constant negative value.
This is the diagram of Sam shooting the basketball. The time it took for the ball to reach the hoop was about 1 second, and Sam releases the basketball at 2.467 meters. Sam is 4.876 meters away from the hoop, and the hoop is 3.048 meters tall. This is the analysis of the motion of the basketball. So we know that the basketball is stopped 3 times during its flight. First, when time equals 0, or before she releases the ball, 0.584, which is when the ball reaches its max height, and 0.934, or when the ball reaches the hoop. Because the object is at rest, the velocity will be 0 for all 3, the acceleration will be unknown, the speed will be 0, and the direction will be at rest.
In between the time of 0 seconds and 0.584 seconds, the position of the ball is moving up, which we decided to make positive, making the velocity positive, the acceleration negative, and the speed slowing down. The velocity is going to be positive because it is moving up in a positive direction, and the acceleration is going to be negative because gravity is working against it, and that makes it negative. And then the speed is going to be slowing down because the velocity and the acceleration are different signs. In between the time of 0.584 seconds and 0.934 seconds, the position of the ball is moving down. This makes the velocity negative because the position is moving negative, and the acceleration negative because gravity is always pulling it down, and the speed is speeding up because both velocity and acceleration have the same signs. During the time in which the ball was released from Sam's hands and the time in which the ball reached max height, the ball was moving in an upwards direction. In the time from which the ball reached max height into the time in which the ball entered the hoop, the direction was moving down.
As we see in our position versus time graph, Quinn's hypothesis was correct. The line is quadratic.
Velocity is the first derivative of the object's position equation, and acceleration is the second derivative of the object's position equation, or the first derivative of velocity.
In our velocity versus time graph, Quinn was correct in determining that the line would be negative and linear. At the start of the line, it is going to be positive because that is when Sam first released the ball. And when the line hits 0, that is when the ball is changing direction.
An object is in motion when it is continuously changing its position relative to a reference point and is observed by a person. This relates to velocity because velocity is a measure of how fast the object is going in a given direction, which also relates to acceleration because that is the increase of velocity over a period of time.
In our acceleration graph, it is clear to see that Quinn was also correct in saying that the line would be constantly negative. This is because our acceleration throughout the entire graph was negative, and acceleration was a constant value.